A delivery service owns two cars that consume 15 and 30 miles per gallon. Fuel costs 3 per gallon. On any given day, each car travels a number of miles that is independent of the other and is normally distributed with mean 25 and standard deviation 3 miles. Calculate the probability that on any day the total fuel cost will be less than 7. So the mileages are 15 miles per gallon and 30 miles per gallon. And since we are given that the number of miles for each car is normally distributed, so that will be our first variable. Let X be the daily miles by a car that does the 15 mpg, and Y be the daily miles by the car that does 30 mpg. Okay, so now since eventually we are talking about the fuel cost, so we have to find the gallons because we are given that the cost is 3 per gallon. So if we know how many gallons each car consumes, then we multiply that number of gallons by the cost per gallon to get the total cost. So um, it's X miles for the first car and it does 15 miles per gallon. So we want to get gallons out of this information. So units are our big help in these scenarios. That I could see that if I have X miles on the top, I have X miles, and I divide it by 15 miles per gallon, then I could see that the miles are canceling out and this gallon is in the third line, so it comes back into the first line, right? Just like the fractions, like if you have x over 5, then the x's cancel and the 5 comes in the first line. So I get the x over 15 and the gallons comes in the first line. So this is x over 15 gallons. That's the number of gallons consumed by the first car. Similarly, for the second car, it goes 5 miles and it does 30 miles per gallon. So if I divide, it goes y miles, and when I divide y miles by 30 miles per gallon, I get y divided by 30. Miles and miles cancel out and I get gallons. So now I have the gallon consumption of both cars, x over 15 for the first and y over 30 for the second. So C, let's see be the total daily cost of the fuel. And that would be 3 times the total daily gallons, because the cost is in cost per gallon. The 3 is the cost per gallon. So if you multiply that by the total daily gallons, you'll get the total daily cost. And the total daily gallons are obtained by adding the gallons of the two cars, the gallon consumption of the two cars. So therefore, cost would be 3 times x by 15 plus y by 30. And that simplifies to 0.2x plus 0.1y. And now C, we have to find the probability that this C is less than 7. So now first let's look at what C is. It's a linear combination of these two normal variables, x and y are normal. And we know that if x and y are normal, then ax plus by is normal for any constants a and b. And therefore C is normal. And now we also know that if the mean of x is nu x and the mean of y is nu y, then the mean of the ax plus by is a mean x plus b mean y. So for the 0.2x plus 0.1y, which is what C is, the mean will be 0.2 mean of x plus 0.1 mean of y. So mean both cars have mean of 25. That's given in the problem, that the number of miles traveled by the first car is normal with mean 25, and that number of miles was x. So mean of x is 25, mean of y is 25, and that adds up to 7.5. That's the mean of C. And the variance of C will be like A squared variance X plus B squared variance Y plus 2AB covariance XY. But we're also given in the problem that the number of miles of the two cars are independent. Each car travels a number of miles that's independent of the other. Therefore, X and Y are independent, which means their covariance is 0. So this part is gone. So we just get variance of C equals 0.2 squared is 0.04. And variance of X would be 9 because we are given that the standard deviation of X is 3. Standard deviation is 3. So variance would be the square of that. Square of 3 is 9. Okay, here 0.04 times 9, and this one would be 0.01 times 9. Variance of Y is also 9, and that ends up being 0.45, and standard deviation of C is the square root of variance, the square root of 0.45. So now we have all the information. As we said, we want probability that the total cost is less than 7, so probability C is less than 7. Therefore, we will need to change 7 into Z-score. So Z is equal to 7 minus mean of C divided by standard deviation of C. Mean of C we calculated to be 7.5. Standard deviation is square root 45. So this ends up being negative 0.75. So probability C is less than 7 is the same as probability Z is less than negative 0.75. The tables don't have negative values, so by symmetry we see that this is the probability of Z being greater than 0.75. And now again the tables go in the other direction, in the cumulative direction, which is less than or equal to. So we change that into 1 minus probability Z less than or equal to 0.75. And now let's see from tables, 0.75 corresponds to a cumulative probability of 0.7734. This one, 0.7734. So 1 minus 0.7734 simplifies to 0.23, correct to 2 decimal places, because the answers were to 2 decimal places. So I rounded this result to 2 decimal places, which is 0.23, and that was choice B.